Astronomers have found a hot, rocky super-Earth that has existed since almost the dawn of our Milky Way galaxy. It could profoundly alter the search for intelligent life. Around 280 light-years distant, TOI 561b is a rocky world a third bigger than Earth that orbits its star in just 10.5 hours. It's thought to be around 10 billion years old, twice as old as the Solar System when the majority of stars in our galaxy were first beginning to shine. The Milky Way is about 12 billion years old. The confirmation of TOI 561b demonstrates that rocky planets may have been forming for most of the history of the universe. TOI 561b is one of the oldest rocky planets yet discovered, said Lauren Weiss, team leader and postdoctoral fellow at the University of Hawaii. Its existence shows that the universe has been forming rocky planets almost since its inception 14 billion years ago. The team's paper was presented at the recent 237th meeting of the American Astronomical Society and will appear in the Astronomical Journal in February 2021. It means that rocky planets have potentially been forming for the past 10 billion years and perhaps all 12 billion years of our galaxy's history, said Weiss. Imagine what could have happened on a rocky planet that's been around for 10 billion years. I'd sure like to find out. Astronomers have found 3 planets TOI 561b, TOI 561c and TOI 561d using NASA's Planet Hunting Transiting Exoplanet Survey Satellite (TESS) Space Telescope and Keck Observatory in Hawaii. They're orbiting a star called, you guessed it, TOI 561, which is a star in the galactic thick disk, and that's what makes this discovery so important. Here's what else we know about TOI 561b and its star. It's 280 light-years distant in the constellation of Sextans, the sextant, a faint constellation in the southern hemisphere's night sky. It's a rocky world 1.45 times the size of Earth, and about 3 times its mass as SuperEarth, though it has a similar density, which suggests that it's very old. It orbits TOI 561, a metal-poor orange dwarf star that's one of the galaxy's oldest at around 10 billion years old. The planets are around the same age, making them among the oldest exoplanets yet found. It orbits its star in just 10.5 hours, making TOI 561b an ultra-short period planet, USP. It's tidally locked to its star, so has a permanent desitifats, likely home to a magma ocean. Most spiral galaxies like our own Milky Way have 2 disks, a galactic thin disk containing dust, gas, stars, and planets along the plane, and a galactic thick disk that hosts metal-poor stars. It's thought that their lack of metal, principally iron and magnesium, means that stars in the thick disk lack planets. Most planets found by astronomers orbit stars in the thin disk. However, that's not the case with the TOI 561 star system, which was found in the thick disk where planets are not thought to form around stars. That makes TOI 561b one of the first confirmed rocky exoplanets found in the thick disk of the Milky Way, and suggests that rocky planets have been evolving since the beginning of the universe around 14 billion years ago. That suggests that ancient lifeforms may have existed for many billions of years. Stars in the galactic thick disk may have formed in an ancient galaxy that later merged with our own, or they could be the first stars that formed within the Milky Way. I wonder what view of the night sky would have been accessible from the rocky planet during its history, said Weiss. TOI 561b hints that rocky planets may have been forming for most of the history of the universe. I wonder if any of them have anyone on them we could talk to, said Weiss. TOI 561b likely does not host life now. Not only does the planet orbit its star twice every Earth day, but it orbits so close it's just way too hot for liquid water to exist on its surface. It's got an average surface temperature of 2,500 K, 4,000 degrees Fahrenheit. However, though the daytime side of TOI 561b is likely to be an ocean of magma, the nighttime side could be hard rock. Most likely is that TOI 561b is a clue that there are many more rocky worlds yet to be discovered around our galaxy's oldest stars that could still be habitable and therefore just might be home to very ancient lifeforms. After all, the earliest forms are thought to have taken at least 1 billion years to come to be on Earth. So the older and more stable the planet, the more likely it will host some kind of lifeforms. I would more readily bet on a 10-billion-year-old star having some intelligent civilization on a rocky planet around it rather than a billion-year-old planet, said Weiss. It's more or less the same density as Earth, which suggests that it's old. Why? You've heard Carl Sagan's quote, "We are all made of star stuff," right? Well, so are stars and planets. Metals heavier than iron are forged in the interiors of collapsing stars and spread out into the cosmos by supernovae. Planets form from that star stuff. So if a star or planet is low metal, it must have come to be long ago when fewer supernovae had occurred. It turns out that stars being metal poor is not a challenge for forming planets early in the universe, said Weiss. Metal poor stars are just as good as metal rich stars. That's a surprise. TOI 561 has two other, less dense planets transiting the star, both of which have about twice Earth's radius and are too large and low mass to be rocky. TOI 561c is 2.9 times the size of Earth and orbits its star every 10.8 days. This one is confirmed. TOI 561d is 2.3 times the size of Earth and orbits its star every 16.3 days. This one is merely a candidate planet. Launched in 2018, the Transiting Exoplanet Survey Satellite, TESS, spacecraft studies sections of the sky in search of stars that periodically dim slightly. That's a telltale sign that a planet is passing across it from the point of view of TESS. Astronomers then follow up and make more detailed observations, as this team did use Keck Observatory's high-resolution Eshell spectrometer, HIRES, in Mauna Kea, Hawaii.